sirs and cadets, good afternoon.
Sir.
So I have I am going to present now my project, which is now the gadget which is generating high voltage. So from the 220 volts single phase, which is generating around 3 phase at 800 or 1000 or higher than that. So actually my gadget is about electronics. Actually it is totally electronics in the sense that it is not using the output of transformer. So it is using the IGBT. So providing higher voltage. Out of single phase, we can generate higher voltage, higher than 220 volts, which is around now. So far, this is generating 850 volts. So it could be increased out of changing some of the supplies. Considering that the supply is out of 220, we can multiply it much higher and higher to attain as to whatever the required for the equipment to run. So actually, the main aspects now as to increasing is that the financial aspects. So in terms of economical aspects, we can increase it, but it entails about much higher costs. But it is possible to increase. However, you have to look for the IGBT, which is much higher capability on handling the voltage. So far we have this 1500 volts IGBT. So we are introducing about 1000 volts right now, and the output is around 870.7% of the peak voltage being the output of the gadget. So our purpose now, the purpose of this project is to have these simulations, to simulate the much higher voltage in actual activities on board the ship, wherein we have this voltage. It is we are not complacent anymore to conduct testing with the given perimeters. So exactly we have the perimeters, we must have to do it in the proper way, because if we do miss that thing, might possible as well on board the ship. We can you can encounter some of the problems on board the ship. So this is emphasizing there is a presence of high voltage. So my gadget here is that I am now connecting this to the bus bars right now. So this is the setting wherein the gadget is now being interfaced into the bus bars. So in consideration, during the time that you have to check the voltage using the non-conductive detector, so you can check with it. So be aware always. This is now much said to be that should be proper. Okay, so we have the gadget now being installed. This is the electronic high voltage power supply. So be careful, guys. So by the our instructors here, by the aid of our instructors, we can have you have the activity right now. So using the what activity number is that by Sir Jack and Sir Sabiniano. So we have this activity wherein yes, you have to do it properly with the proper PPE and proper procedures, and should have to mind always on the safety. Okay, so Sir Jack.
Okay, so yes, I'm engineer Jack Nayakaido. I'm a maritime electro-technical officer and also accredited instructor assessor of the NTC, Norwegian Training Center. I am joined by my co-instructor, now serving as the cameraman. Sir Rod, kindly introduce yourself as well.
Hi sir, good morning. Good day to everyone. I am Electro-Technical Officer Ralph Sabiniano. So we will be performing and we will be simulating the practical activity wherein we're going to perform the isolation procedure of a high voltage equipment with the actual high voltage. Actually, it's a medium voltage. It's 850 volts as what Sir Banson said. From his electronic gadget. The input is 220 volts and we're going to step it up to 850 volts AC, three phase. Okay.
Okay, thank you for that. As well, we are also joined by our ROV cadets. They are also licensed engineers. They are future marine engineers also. So for electrotechnical section, so they are currently licensed electronics engineer and electrical engineers. So altogether there are 12. And then yes, as mentioned, we will be doing the activity high voltage preparation. So with the safety precautions, proper PPE and everything. So one of the equipment that we will be using is this non-contact voltage detector. Okay, so this is the non-contact voltage detector. The parts are, this is the sensor, this is the on-off button, the test button, the low and the high range. Now low range is actually 30 volts up to 1500 volts AC. And your high range will be 1500 volts AC up to 122,000 volts. So as mentioned earlier, that the current design, due to the budget consideration, but also possible to be exceeded, the current design is the input is 220 volts single phase, and the output, the result of the project was 800 volts, 800 volts AC, three phase. So from single phase 220 to three phase 800 volts, yes, AC. Okay, so with that, yes, we will be using this non-contact voltage detector on low range, and then to show you that really the presence of voltage, the high voltage is on the line side. All right. So what are the advantages of this device? Okay. So this is Sir Banson's output, the electronic high voltage power supply. As you can see, this is very compact, and normally, in order for you to have a high voltage source, you will be needing generating sets or either transformer, and thus that will be very massive, very expensive, and space consuming. So with that said, the advantages of this device given to us by Sir Banson will be less space requirement, less cost obviously, and then less installation cost also, and portable. It is very portable. Anywhere you can inject it to your activity. So any activity, any component you wish to have. And the main advantage, as mentioned earlier, is not only you will be imagining the high voltage interaction, but here you will be having this high voltage, and then since we are complete with the lectures, discussion, the equipment, safety precautions, then we must be geared to be with this high voltage. Okay, as mentioned, this is right now 850, but can be designed into greater than voltage to exceed that voltage. And for our marine applications, typically can be 3.3 kV up to 6.6 kV, the normal marine application. All right. So yes, let's do the activity first. To show you the parameters we are using, the input voltage. Kindly measure the input voltage.
Okay, 230 volts.
Okay. Now the voltage on the device. Kindly measure the three-phase voltage whenever we switch it on. Okay. So let's switch on the device. Okay. electronic high voltage power supply.
Okay, so voltage between R and S 700 about 786 volts. Okay, so let's try R and T. Voltage between R and T about 786 volts. And terminal S and T 787 volts AC. So we have an output of 3-phase 787 volts AC. Now we try to measure also the voltage output here on our bus bar inside the switch gear. To verify. Okay. So that is RNT. Terminals RNT 788 volts AC. RNS. Okay. 789 volts. Careful. SNT 787 volts. Okay. So we have 3-phase AC voltage here on our bus bar 3-phase inside the switch gear.
Okay, so we're about to do the activity, racking out of the circuit breaker, and then we have the line side. So we have voltage on the line side. And then also to emphasize, this model, which is with the maker Ampro, with the model TIC 300 Pro AC voltage detector, this one is designed to detect that such voltage, which is around 800 volts, with the distance of even 27 inches. So that's around 2 feet and 3 inches. Okay, so later on we will show you that in order the moment we wrap up. Okay? Videos can be prepared.
So safety first, we are using the high voltage PPE category 4 as per NFPA 70E. Now that the high voltage circuit breaker inside the switch gear has drawn out, we will try to access the high voltage pouch or the terminal on the bus bar, or the three-phase terminals on the bus bar side.
Jonathan?
Medyo lang yung konti.
Dito ka pala sa kaliwa na lang pala, sa may pinto. Para kasi diyan siya makapwesto. Yeah. Okay.
Okay.
Yes, very good.
So those are the high voltage pouch or the three terminals coming from the bus bars. We will try to use the non-contact voltage detector to verify if those terminals are live. Okay. So line 3 is verified as live. Try line 2, okay. So it is also live. And line 3, or sorry, line 1, it is also live. Okay, now we measure the terminals again using the digital multimeter or the voltmeter dito sa terminals.
Okay, so yes, we let's measure the voltage there. So you open and then hindi ako.
Hindi.
Hindi, ano lang, hand stick kaya extension.
Oo. We use the hot stick na lang, sir.
Hand stick pang- yung
Tinapos.
yung pag ganun sa hindi niya daw.
Oh, sige. Okay na yun, sir.
Okay na, sir. So actually, yes, we have verified the presence of voltage on the line side. So again, as stated earlier, one of the main advantage of this high voltage, electronic high voltage power supply is that it's portability. So not only we can inject voltage here on the switch here, but everywhere as well. And it has this protection also, circuit protections. So whenever you get short circuit, you are also protected. So this will be automatically interrupted. Alright? So, what can you say about the project, guys?
So from now on, I have my questionnaires survey regarding as construction, design, and installations, and so we have the effectiveness of the instruction. So actually, efficiency as to the gadget works properly. It will generating voltage, which is the main objective, and to rate also the effectiveness of this gadget for the instruction. So I have the questionnaires right now. So kindly, no, we have this what we call the introductions, or just read the instructions as to how to rate the net. So and according to your feelings and whatever your notions right now, is that good for you, or it is you have to rate from 1 to 3 anyway. So from now on, I will give the questionnaire. So kindly rate. Okay.
Okay, so